Hey everyone, welcome to another BTM screencast. Today we will be going over Chapter 35, Layout and Constructions of the Floor Frame. So in order to construct a frame, you need to know what the members are. So a floor frame consists of girders, which we covered previously, and posts or columns, sill plates, joists, bridging, subflooring, and blocking. Now here we have a picture illustrating all the components. So here we have a column, we have our girder, which we spoke about previously, this sill plate coming along the foundation. These are pressure treated, that's why it's shown as green. Running here, we have all of our joists. Here is a rim or a band joist. Now these run perpendicular to your joists. Here we have our subfloor. And right here we have some of our blocking. So girders are heavy beams that support the inner ends of floor joists. They could be made of solid wood, built up wood, or steel, mostly I-beams. Ends are supported in pocket formed into the foundation wall. And what that means is, let's say we're looking at a wall from the top. This is our wall, and you might have a beam pocket cut in right here. And of course, looking at that this way, this would be our beam pocket right here. Here's a better picture. Now we can see where the beam pocket is, right here. This is a triple beam with 3 pieces sistered together. Make sure you have a 1/2 inch clearance on both of the sides, and there needs to be a minimum of 3 inches of bearing. So where your beam seats in here, this has to be a minimum of 3 inches. When you install girders, steel girders usually come in one piece and they're set in place by a crane. Built-up girders are constructed in place as the ones that we saw in the previous slide. Girders should be straight, level, and plumb over any posts that they sit on. There should be a 1/2 inch space between the ends and sides of the girders. Sills, which we went over, are mostly pressure treated. Horizontal members fasten directly to the top of the foundation. That's done through anchor bolts. They provide the bearing for floor joists to sit on. And as I said, they're attached with anchor bolts. The sill sealer is applied between the sill and the foundation. It's a pink or a blue foam. We'll have that in lab. And they may be installed in different positions. So here's an example of sill plates. They're called mud sills also. Here, this is our pressure treated one, and we can see this has to be at least 6 inches. And over here they doubled it up, so we can see that the corners overlap. Here's one corner, here's the other corner. Regardless, here's the anchor bolts that sit down in the foundation, and that's what anchors the house to the foundation. Here's 3 different ways that sill plates can be installed. So on this one, this sill plate is flush with the exterior surface of the wall right here. On this one, it's set back the thickness of the wall sheathing, so 1/2 inch, maybe more, depending on what the finish is going to be. Now on the last one, we have the setback for the sheathing, again 1/2 inch or more depending on what's required. And then here we have a shelf, also called brick ledge, for a masonry veneer to go up the face of the house. So here's an example of how you can set anchor bolts and drill the holes for the wood that you need. So you could snap a chalk line on the foundation wall, and that's where your sill plate would sit, right here. Align the sill plate against the anchor bolts parallel with the chalk line, so you're running with the chalk line. Use your speed square to draw lines on both sides of where your anchor bolts are, and measure each bolt distance from the chalk line transferred to the sill. So in this one, we would measure this distance, and then we just come up here and measure that distance. Here we measure that one, and here we measure that one, and same with this. Drill holes approximately 1/8 larger than bolt diameter. So if these are 5/8 inch bolts, you would drill your holes at 3/4, and that allows for any play that you may or may not have. Now, sometimes when you have a wall, and let's say your anchor bolts look a little bit like this, but they're still within tolerance. And if you go to put in your sill plate like they showed in the last slide, you'd run that way, or you'd run it that way. It just wouldn't work out too well. So one little trick that you could do for it is you still snap your line, right? So we have our anchor bolts here, here, here. You could still snap your line coming down. And you can take a combination square or make another type gauge. So if you use your combination square, you cut a little foot out of it like that, so it goes around your bolts. Of course, this looks something like that. Not an artist, so. But we can set up this side of our combination square along the line here and have that come into where our bolt is, and then we're able to take that and transfer it over to our sill plate. So instead of using measurement, we're using a gauge. Floor joists are horizontal members of a floor frame. They are generally spaced at 16-inch intervals on center. Generally, depending on the type of floor that it is, they could be closer or they could be further apart. Spacing allows plywood panels to have support at both ends because they're on 16-inch centers. Our plywood panels that we use are 4 feet by 8 feet, and those are each divisible by 16. Joist bearing is minimum of 1.5 inches, so a joist needs to sit on your plate a minimum of 1.5 inches. Joist overlap is minimum of 3 inches, and the max is 12. So if you're sitting on a beam with your joist or a girder, you need to have at least 3 inches lapped. So let's say this is our I-beam here. This lap between this joist and there's one behind it. We'll do a hidden outline. This needs to be a minimum 3 inches, the overlap that they're sitting on. And it also needs to be a minimum of 1.5 inches that's sitting on it. The reason that you can't have more than 12 inches for overhang is because it'll cause your floors to squeak, and no one really wants that. So joists could be framed, they could overlap on the top of a girder, they could be butted on top of a girder, they could be butted flush to a girder. In that case, you need joist hangers, or you could do mix of methods. Wood eye joists require special consideration. We won't be using those in this class. So here's an example of some of the ways that joists can be fastened. So on the top, they're using a joist hanger, so they're being anchored directly to the girder. On this one, we can see that they're being on top of the girder with a minimum of 3 inches of lap from here to here. On this one, they're being butt up against the girder, and we can see that there's a ledger strip here for them to sit on, and they just get butt right up against it. Here's another example. This is sitting on top of a beam, an I-beam. Same, 3 inches of lap. Make sure that the joists are nailed together and that they're held in place by two 10-penny toenails on each side. On this one, these are butt up into the beam, and then we have a piece coming across, and then 2 8-pennies into each joist. Here's more examples of more applications. These are more in depth than what we will be covering in the class, so don't spend too much time looking at these. It's important to follow rules when notching and boring joists. Holes need to be located at a certain distance from the top, and you're only allowed to take out so much of a joist before you affect the structural integrity of it. Again, that's beyond the scope of this class. So here we are installing joists on a sill plate, and you can see this one will come to here and set back 1.5 inches here for our rim. And the same with this one, and same with that one. Now you can see where they have their line right here, and then an X. So this joist will sit on top of the X, and you should only see the line. Same with this one. Here's the X, and our joist will be sitting on that line on top of the X. And the same with that one. Locations of joists are marked on the sill. And the layout for floor openings involves cutting joists to make the opening, which we'll be going over shortly. Layout on a girder and opposite wall follow the same line, only the X is changed. So what that means is if we're laying out and say, here's our sill, here's our sill, here's our girder, we know that we have our center line coming through. If we make an X on this one, it'll also be X'd here, but then with our overlap, it'll be X'd there, and then X'd there. So here we are laying out the first joist that we're going to have, and then it sets the tone for the rest of them. So you can see we go from our outside corner here, and when we come up, we don't go 16 for the first one. We subtract half the thickness of our joists. They're usually 1.5 inches, so we come back 3/4. So then this first one is 15.25 inches. This is our setback, 3/4 of an inch. After we get our 15.25 inch setback, then we can start laying out on our 16-inch centers. So here's another example of a partial floor frame. Of course, we have our rims right here. our joists coming up. Here's our girder. So we know we need a minimum of 3 inches overlap. And here we have a floor opening. In this case, it's most likely for a set of steps. So in here, where this terminates, we have our header, and we also have a header over here. And we also had an extra joist coming up here, an extra joist coming up here to help reinforce that opening. Another thing you might see is a doubled for partition support. So there may be a partition wall going in here, or there may be something that requires another joist put in. In that case, these would be sistered together. And another example is a spaced partition. So if we're going to have a chase coming up here with plumbing, electrical, or some other utility, and then we're able to go and leave these gaps in like that, and then it makes it easier for the next guy to do their job. So here's an example of what we went over before. So we go and we're laying out, and this should be 15 1/4 to start for your setback, because the joists, you start with your 16 and you come back your 3/4 of an inch, which give you 15 1/4. From there we begin our 16-inch on center layout, and we can see here when we lay out our joists right here coming up, we're laying it on this side, so our X is over here. Coming up, our X is still there, our X is on that side of the line, and then of course coming up here, our X is on that side. So when you install floor joists, always make sure that the crown side is up. And of course, by crown, if you sight the wood and it goes like that, that's the crown going up. And the reason for that is it's easier to push down rather than having it go upside down and you installing a sag in the floor. Overlap joists are nailed to the girder and each other. And when you're installing them, if you put up a nailer, a strip of wood tacked to the joist tops, it helps keep them aligned before you put in any of your bridging or blocking. So here we have an example. This is the strip right here, and this little nailer allows all of them to be lined up until the bridging and everything else gets installed. So when you double floor joists, use them for added strength if it's necessary. Again, it depends on what's going to be in the room. If you're going to have a jacuzzi or anything like that, you need more support underneath. They must be fastened securely together, and they must be flush before nailing them together. If they're not flush when you nail them together, then when you're done nailing them together, they won't be flush. Nails are spaced about 2 feet apart, and you don't let any of the nail heads stick out or the points of the nails stick out. So here's an example of how you can do that. They're using toenails here. These are offset a little bit right here, because as you drive these in, this top edge is going to want to go down. When you're framing floor openings, large openings should be framed before the joists are installed to make installation easier. Generally, when you're laying out for these, you mark it in a different way. It depends who you're working with or what the opening's for, and those will be laid out on the sill. How you order it ensures each piece is face nailed, so you don't need to toe nail them together. You're able to face nail them, which is a little easier. So here we have an example of a floor opening. So if we start right here, we know we have this joist here, we have this joist here. we're able to install the outside headers here, so we could face nail in this direction. And then we install our tail joists, and then we're able to face nail in this direction. As we continue, when we install the inside headers, again, these are able to get face nailed. And we're able to come in, and also with our outside joists, we're able to face nail these as well. And after we're done with the opening, because we laid everything out already on our 16-inch centers, we can work backwards or forwards depending which way you're going, and install your regular joists. So bridging is installed in rows not more than 8 feet apart. The reason for that is wood that has a distance of more than 8 feet will tend to be shaky and it's easy to move. You can use solid or cross bridging. Wood cross bridging may be laid out using a framing square. So this one we won't be doing in the lab, but we will be doing the solid bridging. The installation always follows a chalk line. So here's an example of the different types of bridging you can do. In lab, we will be using the solid bridging, and the reason that you can go by a chalk line is because if we look up here, if we snapped a line across these joists, we know that we can install this one on that side, that one there, here, here, here. Again, this type of bridging we won't be covering in the lab. Columns are used to support girders. They can be made of wood or steel. Generally, they're steel. The column size is determined by the engineer or the architect, and that'll be on your blueprints. Permanent columns are placed after the floor joists and before any more weight is put on the floor. Some of the permanent columns, they could be flush mounted to the floor, or they could be poured into the floor also. And here we have an example. So in this case, this column will be poured into the floor. We can see that there's a footing for the column. Column comes up and the girder sits on top. Subflooring, you use over joist to form a working platform and a base for finished floor. APA rated sturdy floor is used as a single layer subfloor. And this one, don't get too caught up on that. So here we have an example of our subfloor installation. It's always run this way. Across the joists, never with them. So if we do have this one, let's say that this piece is crowned, by having this one here and then having this one come over here and overlap, we may be able to help push it down by fastening the rest of these. Running it perpendicular also gives it more strength than if we had run it in line. If this joist here did have a crown in it and we ran the plywood in this direction, this entire section of the floor would have a crown in it. Whereas if we run it this way, if this has a crown, we may be able to take the crown out or at least reduce it. When you apply the subflooring, when you install it, the subfloor is installed in rows, and the joints are staggered with every butt end landing on a joist. So what that means is that every butt end splits the joist. So if we have our joist right here, the butt end of the plywood will be about center of it, and then the next. So it would look something kind of like that. Now here's an example of installing it. You can see that in the top picture, they come off the edge 4 feet and snap a line. And they start the installation with full sheets of plywood. So we can see them here. And the fall off on the end. Now, this same measurement should carry over to here, and then we're able to use full sheets coming up that way. But you can see that each of these are staggered, so none of them end on the same joist. And then when you're done, your floor should look something like that. Now, 2 things to go over when we're installing our joists to the sill. So if you remember, say this is a corner of our wall. We'll run that one there, that one there. And this is our sill. When our joists come up and we go to install them on our 16-inch centers, we need to make sure that these joists are held in place to the sill with 3 8-penny nails, and these would be toe-nailed in. So each joist gets attached to the sill with 3 toe-nailed 8-penny nails. When we install our rim joist coming down, so we'll put our joists, again, 3 8-penny toenails going into the sill. Our rim ends up getting toe-nailed into the sill also, but on this one, 6-inch on center 8-penny nails. So each one would get driven in. Six-inch centers. Now when we install our subfloor, we saw what this looks like here. So we know, and we would have our 16, well, let's start with 0 inches, 16, 32, and then 48 inches. So our joists are running this way. For the plywood that we'll be using, which is 3/4 inch, in order to fasten this according to code along the edges, we need to have 8-penny nails on 6-inch centers. So again, along the edge, 6-inch on center, 8-penny nails. And then coming up on the intermediate, we need nails every 12 inches. And those will also be 8-penny nails. So we'd start here, 1, 12, 24, 36, 48. And of course here we'd start 0, 6, 12, 18, 24, 30, 36, 42, 48. Here's an example, a nice picture of some joists being butted into a girder and put in place with joist hangers. So in conclusion, floor frame consists of many members, many of which we went over. Girders support the inner ends of joists and are supported by posts and columns. Sills rest on and are bolted to a foundation. Joists are the floor structural members, and subflooring is the first layer of the floor.